And now let's talk false position or um all right guys, welcome. Now let's talk false position or Regula-falsi or sometimes interpolation method. So this method is actually also simple. You don't need to differentiate here, but you just need to be smart when doing this so you don't input the wrong thing into calculator. So let's just dive into it real quick. So this is again our f of x. I remember I said sometimes they might twist the question whereby it's not equals to zero, but always equate it equal to zero. So here, okay, we are given x is equal to 1, right? So when we input 1, we got a positive 1, but we don't know our negative sign. So we tried another number backwards and forwards. If you tried 2, I'm sure 2 would have given you positive. So that's why they tried 0.5 and they gave them this. But if 0.5 are giving them positive again, I think all they'll do is they'll try negative 0.5 or negative 1 and whatnot. Just try any number. Make sure you get a plus here and a minus here. And this is where you're inputting those number. 1 will substitute x, 1 will substitute x here. So yeah, that's where you input that. On the other hand, this is the formula we need to know here. Sorry, this formula here, which is, for me, this is how I write the formula. I first of all write a minus b, right? So I know that I'm going to have opposite sign here, opposite sign. So if I have a here, I know I have f of b here minus b. So I know if I have b here, I'm going to have f of a here, and I know, okay, whatever I have here, I'm repeating it down here, repeating it down here. So a minus b first, then opposite of a is b, so f of b. Opposite of b is f of a. So I know whatever I have up here, I bring it down here, bring it down here. Yeah, so there's another thing I figured in this place. Here our a is equal to x1 is a, x2 is b. You get me, I'm used to using a and b. I don't really dabble with this x1 and x2, but let's just, please pardon me when I'm saying a and b and whatnot. So x1 is equals to, our a is equals to 0.5 and our b is equals to 1. So there's something you need to pay attention to here, which is very, very tactical. So for our a here, right, as you can see, a substitutes a here, our b substitutes b here, right? So this one in this equation here was gotten here, right? Remember, it's f of b. This is our b. So there's one thing me I do, and most people might not agree with me, but it's the wise thing to do. I always use my positive as my b and my negative as my a. So some of you might be like, "Ah, but this one is down. Are this supposed to be here? This is supposed to be?" I don't know. But for me, I use positive as b and negative as my a. So remember, we have f of b here and f of a here from this formula. So see b before f of b before f of a. So our f of b is for them is 1, right? This one. Then our f of a, sorry, then our f of a, which is this negative guy here. So as you can see, they are using negative as a, positive as b. So there's something I want you to pay attention to. Now that we got this number, right? This number is our new guy, which is x3, but me, I'll call him c. So this is why I want you to pay attention. Now some of us might begin to argue like, okay, we got our c, and when we are inputting the next equation, right, which one will be our a and which one will be our b? So the first thing you need to notice, whatever you use as your b from the first equation, right, or your a, would remain your A or your B forever and ever. So, sorry, let me just recap that. Now, for example, here, they use this B, right? They use this one as their B. So if you look at the equation, they kept using it as their B in all of the equations. Sorry. So this is, remember the formula is A minus B. Can you see this is their B, which is 1? Again, let's look at another one. We have A minus B. So this is A minus B. Can you see this is 1? So the only thing that changes here is our A. So this is our A here now. See, our x3 became our A. Our x3 is our A here. Then for this guy, which is our x4, it became our A in the equation of x5. Then another thing is, after you get this your answer, you now need to input it into this your equation, right? You need to input it into this equation so you get your f of a and his own answer of this equation. I mean, like, you need to input it into this equation to get his own f of a or f of b, whatever it is use it for. But one thing I'm going to tell you is, be it you use this your x3 as your a or your b, and you use your previous b as your a, like, be it whatever you do, you're going to get the same answer. But just to be on the safe side, if you've been using this guy as your b, using it for your b forever. If you're using this guy, if this is the new guy and you want to use your new guy for a, so just keep up to that pattern. But if you use this guy as your a, then this guy as your b, nothing spoiled, but confirm your answer with your classmates. That's all I can just say, right? Then let's just scroll through to see if there's any. Okay, yeah, like I said, this one you don't need differentiation, so you just need to input it into your calculator. You get your answers and whatnot. So let's just look at the A and B again here. So this is our. I said for me, I'm always taking my negative answer as my A, positive as my B. So let's see what it is as their A. This is A. A is 3.5, right? Okay, it switched for them here. They use 3.5 as their A here, and they use 0.3, which is our 4, as their B here, right? So I don't know why that is that, but I think okay, it means nobody cares. Use whatever you want to use as your A or your B. Like nobody really cares. Just do whatever you have to do. But now let's study the pattern of what happened next. So they use 4 as B, 3.5 as A. So let's go to the next equation. Can you see 4 remained their B? But the new guy, which was our x2 or x3, he came here and became our A, right? So let's see again. Okay, that's all for that equation. So the same thing goes here. Simple equation. Let's see. Is there anything looking funny? Funny, funny. Okay, for this one, we are giving our roots, right? So you need to, okay, yeah, look at this thing now. We are giving -2 -3. So when you put -2 and -3, we got 2 and -4. Can you see? So this one now, don't ever even dare do my -2 plus -3 over 2. You're just gonna be misled because your root is going to be closer to 2. So whatever you are doing, make sure it's closer to -2. So your answer might be -1 or 1. Let's see what's the answer. What did they use? Can you see they use minus 2.125, right? So if you're testing numbers, don't go saying okay, the middle of -2 and -3 is 2.5. Yeah, or whatever. But see, this is the number they use and it got them closer to 0. Can you remember what I said earlier that your number must always be equating equal to 0? So what else again? Let's just see their A and their B. Sorry, what's their A here? Their A here is -2, B is -3. So let's see. A is -2, B is -3. Okay, makes sense. So let's see the next equation. They use their -3 as their B continuously. So I think let's just stick to that. Your B remains constant all through the equations, all through your iterations or approximations or whatever. Then what changes is your A in Newton. Okay, no, this is not Newton. This is Regula-falsi method. What else again do we have? Do we have anything looking funny? I was trying to check through. Okay, yeah, there's nothing else. So yeah, and don't forget you can always input this into your calculator to get an answer very fast.